Hi guys, so this is Venkatesh. Welcome to Venki's Emerging Edge YouTube channel. So today we are mainly focused about LeNet5 architecture. So this explanation only for exam point of view. So LeNet5 architecture. So LeNet5 architecture it is a one type of classical convolution neural network. Is it clear? Classical convolution. It is one type of classical convolution neural network. It can be designed by one of the scientists and Ellicon and others. But here we are mainly focused about the main scientist name Ellicon. That's why this name is called a LeNet. And 5. So what do you mean of 5? 5 means it provides 5 different types of layers. That means in which out of 5, 2 convolution layers, 2 subsampling layers, 1 fully connected layer. Is it clear? It can be developed in 1998. So that's why this is called LeNet5. Is it clear? I think all of you know why it is called LeNet5. It can be designed. It is a one type of classical convolution network. It is designed by the Anne Ellicon and others. So, but here we are mainly focused on first scientist name Ellicon. So the LE is a one type of the neural network CNN. Next 5 means is provide 5 layers, 2 convolution layers, 2 subsampling layers, 1 fully connected layer. Is it clear? Next, why we are developing this layer, this network? The first one is recognizing hand written images. The second one is mission printed characters. Is it clear? Only this purpose we are developing of LeNet5 architecture. Okay. So now the easy explanation of LeNet5 architecture. Okay. So LeNet5 consists of 4 different types of layers. So how these layers are processing in this architecture, then we can easily understanding of LeNet5 architecture. Okay. First one is a convolution. Convolution. First you take input image. The input image size is 32 into 32. Single image. Okay. So 32 width and 32 height. Next. Now we are applying a convolution operation on this image. Finally get a some output image. This output image is called a future map. So how the convolution will be applying? So if you want to know more about convolution neural network architecture, watch my previous video. I will provide link below. Is it clear? Now, how the applying of convolution operation? Okay. In previous video, we already discussed about these are 2 different types of matrices. In between, we can applying of mathematical operation. Finally, get a new matrix. This is called a convolution. Like the same process will be applied. Input image 32 into 32. So here convolution. The convolution can be done by using of kernel or filter. The kernel or filter size is 5 by 5. So what is the size of output of future map? So output size of future map. So output size equal to n minus f plus 1. What is n? This is the input size 32 minus what is f? Kernel filter. What is size? 5 plus 1. Finally get a 28. Is it clear? Okay, 28. So the final output size is 28 into 28. Is it clear? This is a one convolution operation. So these are two different types of convolution operations are done in a LeNet5 architecture. Is it clear? Okay. Now, so input size 32 into 32 into 1. Then we are applying of convolution operation by using a 5 by 5 filter. Then we get some output. Then output is called a feature map. Then feature map size is 28 into 28 into 6. I think all of you know that how to get 28. The output size or output shape is equal to n minus f plus 1. N means the size of input image 32 minus what is f means filter size. What is filter size? 5 plus 1. Finally 28. It is a size of feature map. Clear? After that we are applying of subsampling. Subsampling. What is subsampling? It is also called a average pooling. Is it clear? Then average pooling we can applying of with the help by some size. Then finally we get a feature map. Again feature map. The size is 14 into 14 into 6. So after convolution operation and or after subsampling operation, the final output is called a feature map. Is it clear? Okay, then so these are one type of convolution operation, one type of subsampling. But as per definition, LeNet5 contain two convolution operations plus two subsampling operations plus one fully connected layer. Then we can draw the complete architecture of LeNet5. Clear? So final LeNet5 architecture. So it's contain two convolution layers plus two subsampling layers plus one fully connected layer. Clear? So this is the input size is 32 into 32 into 1. After that we perform the operation of convolution with a 5 by 5 filter, then get a some feature map. The feature map size is 28 into 28 into 6. We know that how to get a 28. After that again we are applying of subsampling. Subsampling means is also called a average pooling. Next again get a some output. That output is called a feature map. Feature map. Then feature map size is 14 into 14 into 6. Again after subsampling we are applying of convolution operation with a 5 by 5 filter. Again get some output. This is called again feature map. The size is 10 by 10 by 6. After convolution, subsampling, convolution, again we are applying of subsampling. So this is also called feature map. Size is 5 into 5 into 6. So here we are applying of subsampling. Finally we are applying of fully connected layer. So this is complete architecture of LeNet5. Two convolution operations, two subsampling techniques, finally fully connected layer. This is called a LeNet5 ప్రాక్టీస్ చేయి. థ్యాంక్ యూ.